Alright, here's something new, another way of solving a triangle. What's happening here is, what I'm about to show you is not the lesson for this chapter. What we're doing here is, I'm going to show you an amazingly annoying and time-consuming way to solve this kind of problem. Then we're going to flip the page and show you the cosine law, which is a better way to solve this class of problem. And you'll be very grateful to have it because you've seen how bad it is to solve them this way. But we'll do this to start off. It's good practice. They're asking us to find the length of BC right here. I'll highlight it red. We want that distance, and what they have given us is a bunch of information about the left-hand triangle. We have 36 degrees there. That's 3 centimeters long. Just from A to B is the 3 centimeters long. And this side here is 6. So, the length of BC, how are we going to do this? Well, the first thing we're going to do is magic up another triangle that suits our purposes better. Here's the idea. This, edged in green, is one big triangle, and it contains this same 36-degree angle at the point. It also has this 6 centimeter side as a hypotenuse. So that's good. We're recycling measurements. And the general plan is, if I can find some measurements for this right-hand triangle, the cross-hatched one, the red line is the hypotenuse of that triangle. I want to get over into here and see what I can find. So I'll try to find this side, which I'll call A. Make that a little darker. Alright, that side is A. That doesn't want to go darker. We'll just switch to black, sorry. Okay, so standing here, this is the opposite side. This is the hypotenuse, so we can say sine 36 equals opposite over hypotenuse. So side A is, what is it? 6 sine 36. Sine 36 times 6 is 3.53. So we'll get rid of that A since it's not an unknown anymore. That side is 3.53 centimeters long. We can actually do that again and find the total length of AD down here, this bottom side. Standing here, this is the adjacent side, and we still have our trusty hypotenuse of 6. So we can say that cosine 36 equals the adjacent side over the hypotenuse of 6. So the adjacent is 6 cosine 36, which is, more calculator action, 4.85 centimeters. Now, that means all the way from A over to D is 4.85 centimeters, and we know that this chunk is 3 centimeters, so how far is that? How far is the little stub from B to D? 4.85 minus the 3 that's over on this side means this must be 1.85. Great. If you look at the right-hand triangle, the cross-hatched one, we now know 2 of its sides. We know we have 1.85 on the bottom, 3.53 up the right edge. The Pythagorean theorem will now get us the hypotenuse that we want. A squared plus B squared equals C squared. 1.85. It doesn't matter which one you call A and which one you call B. The other one is 3.53 squared equals c squared, and again, there is much calculator. 3.53 squared equals square root, and I get that c, or the hypotenuse rather, it's technically side BC, is 3.99, very close to 4 centimeters. So that's one way to find side BC, and shortly you should see that there's another way to solve these kinds of questions that doesn't require as many steps. It requires one big step, which we're going to call the cosine law.